Hello everyone, welcome back to my YouTube channel. In this particular video, we'll be looking into the measure of central tendency. So this is the most important topic when it comes to data science as well as statistics. So first let's have a look at the definition of this particular topic. A measure of central tendency is a single value that describes or summarizes the distribution of a data set. So you can focus on this point. It is a single value. By this particular single value, you can understand how exactly that particular data variable is distributed or is oriented. So, usually, this measure of central tendency is used for a single variable at one time. Single variable means single attribute. It tells where most of the data values are located or clustered. So by this particular single value, you can understand in the entire distribution of that particular values in a particular variable, how they are oriented, where they are actually located in the entire distribution. So there are three common measures for central tendency. They are nothing but first is mean, second is median, and third is mode. So these three are the measure of central tendency. We are going to look into all of this one by one, starting with mean. So you might have heard of mean. Mean is the arithmetic average of the data values. So basically, what all values are present inside that particular variable, we will be taking the average of all the values in that particular data variable. And that is nothing but the mean. It is calculated by adding up all the data values and dividing by the total number of values that are present in that particular data variable. So it's same like finding out the average. For example, if we consider these set of values 10, 20, 30, 40 and 55. So let's consider these particular values are belonging to one single variable. Now we have to find out the mean of all these values. So for finding out the mean, we already know how we can calculate it. First we have to add all these values. So a simple formula for mean can be adding all the values, that is 10 plus 25 plus 30 plus 40 and the last value is 55, and then we will have to divide it by the total number of values. So here you can see there are 5 values, 1, 2, 3, 4, 5. So 5 will come in the denominator. So we have to add the numerator. It comes out to be 160, and in the denominator we already have 5. Now 160 divided by 5 comes out to be 32, and that is what is the mean of all these values. So now that we have seen an example of how to calculate the arithmetic average or mean of the distribution, let's have a look at a simple example of this particular distribution. So over here you can see we have this distribution. Let's say the minimum value in this particular distribution is 10 and the maximum value it is 40. In this particular distribution, the mean is nothing but the average of all the values that comes inside this particular distribution. So it can be any value situated in that particular data variable. So here you can see the mean comes out to be somewhere here. So this will be the mean point. Make a note that it's not necessary that mean will always come at the center. Based on the distribution and the data values present inside that data variable, the mean can come here also. It can come here. It can come anywhere based on the distribution. Just understand the basic idea that it tells us the average value in the entire values present inside the distribution. So I hope you might have got an idea of what exactly mean is. Now let's move on to the next measure of central tendency, that is median. So by the name itself, you might have understand that the median is the middle value of all the data values when they are arranged in ascending or descending order. So you need to make a note of this particular thing is that you don't have to take the entire set of values that are present in the data variable as it is. You will first have to sort it in ascending or descending order. Then only you can apply this particular technique of finding out the middle value. And whenever you find out the middle value, whenever your data values are sorted, then in that case, that particular middle value is called as median. Now, whenever we have to find out the median, there might be two cases. The very first case is that the data might contain odd number of values. That means the total number of value in that particular data variable might be an odd number. So in this particular case, the median is nothing but the middle one. And when we talk about this particular case where the total number of values in the data variable are even in number, then in that particular case, the median is nothing but the average of the middle two values. Because if you carefully observe, in the even number of values, there will be two middle numbers. And to find out the median, we'll have to find out the average of that two middle numbers. So let's have a look at the examples of it. So here is the example. You can see over here, this is the first case where we have total 4 data points present. Here, while finding out the median of all these points, first we'll have to figure out whether these points are sorted in ascending or descending order. Over here, you can see clearly that all these points are sorted in ascending order, so we can clearly go for finding out the middle values. Now, over here, you can clearly observe that these are total 4 points, and this 4 is an even number. So, we have even number of values. So, when we talk about even number of values, we get two middle values. So, in this particular case, the median will be the average of all these two middle values. So whenever we have to find out the median, we'll have to take the average of these two middle values. Now we already have seen how to take average. First, we have to add them, and then we have to divide it by the total number of values that are concerned. Here two values are concerned, so we'll divide it by 2. Here we are taking the average. So 22 plus 30, it is 52 divided by 2, and we get the answer as 26. So the median of these four values is 26. So this was the first case. Now let's talk about the second case where we have the total number of data values as 5. Here you can see there are 5 data values. Now in this, since 5 is an odd number, so we have to follow this particular case. The median will be the middle one. All these are sorted, and since there are total odd number of values, that is why the middle value will be the median. So 27 in this particular case is the median value for these all 5 points. I hope both the cases are clear to you all. Now let's have a look at the distribution in which how median plays a role. So over here you can see that this is the distribution, and let's say this is the median value. Now in this particular distribution, what this exactly tells us that to the left of this particular median, when we talk about these values, these comprises of 50% data points. And to the right of this median, it also comprises 50% of data points. So basically, this median is nothing but the middle value to the left of which 50% of the data points are located, and to the right of which 50% of the data points are located. Now, this doesn't mean that median will always be at the center of the x-axis. We are talking about the bulk of distribution. Over here, you can see this is the total number of data points on the left of the median, and this is the total number of data points on the right of the median. So you can see these will be partitioned by the median and not the x-axis values. So I hope importance of median is clear to you all. Do you want to check out this attractive funny memes? Then what are you waiting for? These are just a glimpse of the memes that I've created on my Instagram page. You can find the link to my Instagram handle in the description box. Please visit the link and do watch all these interesting funny memes. These are not just memes. These memes and reels contains technical information. Here I try to relate memes with the technological concepts. So please do appreciate that by watching all those. And if you love it, please hit the follow button. Now, let's have a look at the third measure of central tendency, that is mode. So, what exactly it is? The mode is the most frequent or common value that is present inside the entire set of data values. So, this is the only key, most frequent values. There can be more than one mode or no mode at all. So in a particular set of data values, there is not always the case that we will be only having one mode. We can have multiple modes, but there can also be a case that there won't be any mode at all in the entire set of data values. Let's have a look at an example. Over here, you can see that these are the data points present inside the distribution. 2, 4, 4, 6, 8. Now, out of these data points, it is said that 4 is the mode. Why 4 is the mode? Because here you can see that only 4 value is getting repeated, or I would say it is the most frequent among all these values. It is the common value. That is why it is considered to be a mode for this particular data points. Now let's take an example of this particular case where there can be more than one mode. Let's say in the data point values, we have some scenario, something like this. Now in this particular case, if you carefully observe, 4 is a mode because it is repeating at least once. But with that, you can also see that 6 is also getting repeated twice. So here in this particular case, with 4, one more mode is there, that is 6. So in this particular case, we have two modes, that is 4 and 6, because both of them are getting repeated most frequently. So this was the case for this more than one mode. Now let's have a look at this particular case where there is no mode at all. Let's consider these set of data points 1, 2, 3, 4. Now in this particular case, there is no single data point that is getting repeated at least once. There are no frequent data points. So that is why there is no modes present inside this particular set. So I hope this particular case is also clear. So I hope it is clear how to calculate mode and what are the conditions for it. Now, if you look at this particular distribution, let's consider that in this particular distribution, the minimum value is 10, the maximum value is 40, and there might be some values. Let's say here it is 20, let's say here it is 25, let's say here it is 30. Now, here, why, why this particular point is considered to be mode? Because you can see that there is maximum number of data points present at this particular value, 25. That means 25 is getting repeated more number of times. It is most frequent. And that is why this particular point is termed as mode for this particular distribution. So let's take one more example. If the distribution is something like this, so in this particular case, this particular point is the point where more number of data values are getting repeated. That is why we'll say that this particular point is nothing but mode. So I hope it is also clear to you all how to have a look at mode in the distribution. And with this, we have covered all the three measures of central tendency. I hope everything is clear to you all. We also have seen numericals of it with the distributions also. But that's not it. I have an important note for you all to keep in mind whenever we are talking about measure of central tendency. Now, the first note is related to mean. The mean is sensitive to outliers or the extreme values. So it may not be a good measure for skewed data. Yes, I can understand there are many terms which are new to you. First term is outliers. So what exactly these outliers are? So for now, just understand that in a given set of data points, outlier is that point which is behaving different than others. For example, if we have some data points like this, 1, 2, 3, 10, and let's say 5. Now, in this particular set of data points, we get one value which is extremely different than others. For example, we get a value 90,000. All the other data points are extremely smaller than this particular one single value. So this value is termed as an outlier for this particular case because it is behaving entirely different from all the different other values. So these are outliers. So it is said that mean is always sensitive to outliers. So whenever in a particular given set of data we add an outlier, the mean will change drastically. Now, why this mean is acting sensitive to outliers? Because just consider this particular case. If we ignore this particular value, let's say this particular value does not exist. Okay. Now, if we take the average of these data points, 1, 2, 3, 10, and 5, we'll get an average which will be extremely smaller. Let's say the average is 7. It's not 7. I'm just taking an example. Let's say the average of these data points after calculating, it is coming out to be 7. Now, if we add this particular outlier in this particular entire set, and then if we try to calculate the average of these data points, including 90,000 this time, it would be around 15,003. Now, just imagine we had an average earlier as 7, and now after having the outlier in the data set, we are getting 15,000 as the value. So you can see it is extremely sensitive. Even one single outlier can entirely affect the mean value. So that is why it is always recommended that whenever we calculate the mean, we should ensure that the particular data particular data variable does not contain any single outlier. The next note is for median. So the median is more robust to outliers, so it may be a better measure for skewed data. So basically understand that skewed data is some data which is not symmetric. Now what exactly is symmetry? Just uh, I'll just tell you at a glance. So over here, you can see this particular axis and the distribution is something like this. In this particular case, if you divide this particular data into half, you can see that we have some sort of symmetry in this particular case. To the left, we have this particular section, which is approximately symmetric to the right of the distribution. So here in this particular case, we have symmetry. So in this particular case, this particular distribution is not skewed. Now, what is skewed then? Whenever we don't have any symmetry, let's say the distribution is something like this. Now, if we try to check the symmetry of it, you cannot say that this is symmetric. You can see at the right we have some sort of more number of data points, and to the left we have less number of data points. The distribution is distorted. That is why it is called as skewed data. So always remember that mean is not going to be a good measure for skewed data, this type of data, and median is a good measure for this particular types of distribution. Why? Because it is robust to outliers. Now, how it is robust to outliers? Just imagine over here you can see that if you consider the same case, we have points 1, 2, 3, 10, 90,000, and 5. First, we have to sort them in ascending order. So let's say we sort them 5, 10, and then we get 90,000. So in this particular case, if we try to first consider only these set of data points, and if we try to calculate the median, we get the answer something like this. We get 3 as the median. Now, when we add the outlier in the data set, then in that particular case, the median won't change drastically. Here, if you calculate the central point, in this particular case, the central point will be 3 and 5 because it is the even number of values. So we'll take the average of 3 and 5, which is nothing but 4.5. So here you can see at a large scale, the median is not getting changed drastically, but mean was getting changed drastically. That is why median is more robust to outliers, and that is why we can use it in a skewed data. So I hope it is clear. Now, let's check for mode. Mode is useful for categorical or nominal data, such as colors, names, or labels. So basically, when we talk about categorical data, we have seen different examples. Like let's say we have a data variable which contains colors. Let's say red, blue, green, orange, green, red. So something like this. Now, in this particular case, we cannot calculate the mean because it is a categorical data. Even we cannot calculate the median because it's not a numerical data. So, in this particular cases, we can use the concept of mode. We can count the most frequent values. Here you can see R is the mode as well as we have G, that is green is also mode. So mode is useful for categorical or nominal data. So I hope the usefulness of all these measures of central tendency with each and every different cases is clear to you all. So that was a great note from my side. I hope it will be useful for you in your life. And with that, we come to the end of the video. We have seen all the measure of central tendency in detail with amazing examples. I hope it is clear. If you guys have any single doubt, then you can straight away put it in the comment section. I'll be happy to solve it. For more such videos, do like, share, and subscribe to my channel. Also hit the bell icon and don't forget to follow me on Instagram. Please join me on Telegram. And thanks for watching. Have a good day.